Hello, welcome to the video. In this problem we're looking at kind of one of the classic situations that we encounter in probability, which is we're calculating a probability based on a deck of cards. So if you're not familiar with a deck of cards, take a minute and read through these lists and it tells you exactly what's included in the deck of cards. How many cards of each type, each color, each number. And also notice that there's a really important piece of information given in the beginning of the question, which is that, there we go, there's a total of 54 cards in the deck. So we're going to need that piece of information, and it will be nice to have it there calculated for us already. Alright, now let's look down at the probability they're asking for. They're asking for the probability, oops, sorry, I'm having trouble there, the probability that the card chosen is a king. So one way we can think about a probability in this situation is we can think about the probability of choosing a king would be the number of events in the outcome of interest divided by the total number of events in the sample space. In other words, let's write that out as a formula. We could say, there we go, we say the probability of choosing a king, I'll write it first as a formal definition, equals number of outcomes an event divided by the number of outcomes in the sample space. I'll use the capital letter S for sample space. So there's kind of generic statistical language. If we think about the event we're interested in here, it's that we draw a king. So what we're really asking for is, well, how many outcomes are in the event that we draw a king? So the number of ways to get a king, or we could think of it as the number of kings in the deck, because each one of those kings in the deck represents a different way to draw a king. Our numerator is the number of outcomes in the sample space. The sample space is the whole deck of cards, so here we're interested in the number of cards in the deck. And I'll put the word total in there because it's helpful to remember we're talking about the whole group. Alright, so now if we go back to our story of interest, or to our given information, to find the number of kings in the deck, if you're not familiar with a deck of cards, you can look through and say, okay, here's one king, it's a black spade king, here's another king, a black club, here's another king, a red heart, and another king, a red diamond. So altogether there are 4 kings in that deck out of the total of 54 cards. So as a fraction, the probability would be 4 out of 54. Notice they're asking for it as a percent, so I want to go ahead and do this division on my calculator. So I'm going to go 4 divided by 54, which when I do that out is giving me the decimal number, 0.07407, so we could round to 0.0741. And then I notice they ask for the probability as a percent, so I need to multiply by 100 there, and it turns into 7.41, but they only want 1 decimal digit, so I'm going to input it as 7.4%. So this could be helpful if you're playing cards to know that the probability of drawing a king is about 7.4%.